And welcome back. As we go ahead and continue looking at classes, we're now going to go ahead and examine method stubs and what those are and how they can work for our coding. So the first thing to talk about when we talk about method stubs is this concept of driver programs. When developing new methods, each method should be tested in a program in which it is the only untested program. If you test your methods this way, when you find an error, you'll know which method caused that error. A program that does nothing but test a method is simply called a driver program. You can think of these as the various demo classes that we've looked at. Another thing to look at is bottom-up testing. If a method contains an invocation of another method in that same class, this, of course, can complicate our testing process. However, one way to test a method is to first test all the methods invoked by that new method, and then test the new method itself. This is what is known as bottom-up testing. Now, that, of course, is going to lead us into this idea of stubs. It is sometimes impossible or inconvenient to test a method without using some other method that we have not yet written or has not yet been tested. In this case, you can use a simplified version of the missing or untested method, or what is known as a stub. These stubs will not necessarily perform the correct calculation, but they will deliver values that suffice for testing, and they're simple enough that you can have confidence in their performance. So here's an example stub. This one says it computes the probability of rain based on temperature, barometer pressure, and relative humidity. It returns the possibility of a fraction between 0 and 1. So a public double rain chance, and we have parameters for double temp, double pressure, double humidity, and it says return 0.5. Notice there's no actual calculations on here. We simply have an expected value. We know we're going to get a double, so let's go ahead and just return a double to see if this performs the way we are expecting it to perform. Now that's going to lead us to our last thing here, which is the fundamental rule for testing methods. Every method that you create should be tested in a program which every other method in that testing program has either already been tested and debugged. And if we pop on over to Eclipse, let's go ahead and take a look at this with a very simple example. So here I have a driver class, and if you look at using the sum class here, sum class, of course, is very simple. You can see we have a instance variable here. We have a get method right here, which is going to just return a string value. We have a void set name, so that's just going to, of course, set the name, which is using this parameter new name. We, of course, also have a method right here. It says stub a method that set the name of a method if a certain name was entered. Right now, we're testing it, for example, if it equals Charlie. Now, this may not be the final form of this method. However, just to test to make sure that it is working correctly, I'm going to have it perform something. Since I know, for example, maybe I want to see if it is equaling a certain name, I can use if name.equals. And that's a great way for me to test that. Or if I had, let's say, a user input, then I can later replace this with that user input variable that would then handle it. But for now, this stub is a great starting point. That's another way to think about stubs, that they're starting points for us to use to really flesh out our program. And of course, then we have a toString and an equals method. If we look at our driver method, or driver class here, you can see we have various methods being tested. We have our set name, we have a get name, we of course are setting the name of a second object, we are calling here the toString method, because you notice it just says another object. Notice there's no invocation here, but remember the sum class does have a toString, which means it will of course just return that value. And then if we look down here, we have if it is equaling, so this is a equals test, and then lastly, we are calling that set name if. So if we go ahead and run this, we get the current name of the object is Charlie, the second object is Bill, testing to see if the two objects are equal. Now notice we do not get the objects are equal because it is not equal here. The names are two different values. Then we are testing the stub method, which of course is set name if, which of course then outprints Charlie, because if you remember in our sum class, set name if just prints out the word Charlie if the name is equal to Charlie. Now, if I had done this with another object here, if I had done it with this one, and had done this one instead, I'm just going to add some space here just to make this a little more clear. If I had done another object dot set name if, we would not have that. In fact, I'm just going to go ahead and show you that real quick here. If I go ahead and rerun this code, we won't see Charlie. So let's run it. No Charlie. And that's because the name of another object is not Charlie. A name of another object is Bill. So, again, a quick rundown with how we can use stubs. But this, of course, leads us into a very interesting thought. We have, of course, already looked at how to use pseudocode to kind of help derive algorithms and different things. And now we can see we can use stubs to kind of help us derive some methods. So maybe we need to find a way that we can kind of take those two concepts and use them to really flesh out our programs.